In this video, I'll show you how to solve the ALEKS problem called deciding whether a Lewis structure satisfies the octet rule. In this problem, you're going to be given 3 different Lewis structures. One of the things that you're going to do is decide whether or not it satisfies the octet rule, but you're also going to be asked to determine whether or not the drawing has the correct number of valence electrons. So it's a little bit more complicated than what the title implies. So let's just start with our first molecule. The first thing that we're going to want to check here is the number of valence electrons. Let's see if that's accurate or not. And as a reminder, we do count up the number of valence electrons by looking at where the atoms are located on a periodic table. When we're looking at a periodic table, as we go across the columns on the periodic table, the row that each one of these elements is in is what indicates the number of valence electrons for that particular element, except for helium, which has 2. Everything else follows the general pattern, 1, 2, 3, 4, 5, 6, 7, 8. So from neon down, all of these elements have 8 valence electrons. So for this first molecule that we're looking at, it is 2 chlorine atoms. Chlorines each have 7 valence electrons. It has a carbon atom, which has 4, and it has an oxygen atom, which has 6. And so that would mean that this particular molecule, if it is drawn correctly, should have 7 plus 4 plus 7 plus 6 valence electrons, which is a total of 24. So let's go ahead and verify that we actually have 24 electrons in this drawing. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that's what's wrong with this. We can say that the structure is not correct, and the thing that's wrong with it, it has the wrong number of valence electrons. The correct number is actually 24, and the drawing instead has 26. So we're done with that one because you can only select one of these options. Now let's move on to our next molecule. Let's begin by checking the number of valence electrons. Hydrogen has 1 valence electron, carbon has 1, carbon also has 1, and this time we have a negative charge. If we have a negative charge, that means we need to add an electron, and we need to add as many electrons as the charge indicates. So if it's a -1 charge, that means we add 1 electron. 1 plus 4 plus 4 plus 1 is 10, so that means this molecule should have 10 valence electrons. Let's count up, see how many we have. 2, 4, 6, 8, 10. So we know that it has the correct number of valence electrons. This is not an option for us. The next thing that we should consider is this possibility in terms of satisfying the octet rule. The octet rule says that hydrogen wants to have 2 electrons around it. In terms of hydrogen, that just means that it needs to have 1 single bond. That's really the only option that we're ever going to see for hydrogen. And all of our other atoms, so everything other than hydrogen, they want to have a total of 8 electrons that will be in 4 pairs. And this is going to be some combination of bonds, lone pairs, double bonds count as 4 electrons or 2 pairs. Triple bonds count as 6 electrons. So we're going to need to analyze these atoms one at a time. Our hydrogen in this structure has its 1 single bond, which it likes. So that means that this hydrogen is happy. Our carbon atom needs to have a total of 8 electrons, 2, 4, 6, 8. So that means this carbon atom is also happy. And then our last carbon atom in the molecule, it has 2, 4, 6, 8. So this carbon atom is also happy. All of the atoms have the octet rule satisfied, which means that this is the correct structure. Everything looks good here. And just to clarify, every bond, every line represents 2 electrons. So if you have a total of 3 lines, that would represent 6 electrons, 2 electrons per line. We've got one more example down here. First thing that we should do is check the number of valence electrons. Nitrogen is in the 5th column on the periodic table, so that means we have 5 valence electrons for each nitrogen, and we have 1 more valence electron for that -1 charge. That's a total of 16 electrons. So we should be able to count 16 electrons in this structure. We have 2, 4, 6, 8, 10, 12, 14, 16. So we have the correct number of valence electrons. Second thing that we want to check is the octet rule. There are no hydrogens, so that means every single one of these atoms should be surrounded by a total of 8 electrons. The first nitrogen that I've circled there has 2, 4, 6, 8, so that nitrogen is good. Let's check the center nitrogen. This nitrogen atom has 2, 4, 6, 8. So that means it also is looking good. And let's check our last nitrogen atom. This one has 2, 4, 6. So this nitrogen atom is not satisfying the octet rule, does not have its octet rule satisfied. And so we'll just enter a nitrogen. This is kind of tricky because it doesn't really give us any kind of guidelines for how to indicate that it's this particular nitrogen. It looks like ALEKS is kind of going a little bit easy on us in terms of how we're going to communicate this information. Just enter N.